Hello, hi. Welcome to the end-to-end demo of the intelligent monitoring of the vehicle. So my name is Praneeth. I'm part of Group 19 of the SPA project assignment group. So let me just brief you through the problem statement, and I'll discuss on the task one, which is the architecture diagram first. So that we'll just go through the architecture on how we design the system end to end. The problem here is that there will be trucks moving in different cities with GPS and other kind of device tracking system split fitted to it, and those will be generated lot of data, like speedometer data, temperature data, humidity, and other longitude, latitude, and all. So since that data comes from multiple vehicles, and that too it can come frequently, so that is a clear and cut case of example of a streaming data, right? So that's why we the architecture needs to be in such a way that it has to accommodate the streaming input, and later the main use case of this project is to do some analytics on that data that we get to figure out the anomalies. Here we can see on the left side the truck data. Coming to the problem statement, right? So they asked us to just replicate the behavior of a real-time truck, which actually continuously streams data to a server somewhere sitting somewhere, and the other end is just streaming the data and then taking it from that and do analytics on that. So normally in such scenarios, what happens in the real world is that these are IoT devices, right? So they just use a protocol called MQTT, which is also similar to it's a broker kind of protocol where you have a broker and you just subscribe to the broker and you publish messages on top of it. So it's like a pub sub where you can just it supports IoT devices, so that's where like it's widely used. So since this is a simulation kind of program, we can't have any IoT, right? So the left part of the diagram we just simulate it, and then rest of it is almost similar. So we have a MQTT broker running on our system, and then we have a you know separate Kafka broker, and then we persist the data, we do analytics, and then if you want, we can visualize the data also. So let me just walk you through the architecture diagram, what we designed for the current code. So as you can see here, this is what the architecture we thought it would suffice for the requirement. As you can see from the left side, it's just the mocking of the IoT device, just like the truck details generator. So this is a Python program which generates data in some kind of 5-second interval from multiple trucks with the latitude, longitude, and all. I'll come to the program, but yeah, so just assume that this is the data source, which actually subscribes to a MQTT broker topic and then publishes the message into that. Later point onwards, so since that is a streaming data, what we do for better use case is that we just push the stream packets into the Kafka cluster. So as of now, for the current architecture, we just have one cluster, but yeah, we can have multiple clusters if you want to scale it more. So what happens is that once the data generator pushes the message into the MQTT broker, we have a MQTT to Kafka connector, which actually publishes the data from MQTT topic to the Kafka topic that is selected. Later point onwards, we just have the right hand side of the architecture. We just thought if you want to do some kind of streaming queries like tumbling window queries or something, you need some kind of persistent layer. I mean, not only for streaming queries, but yeah, for later use cases, if you want the data to be persisted, I had like multiple options like MongoDB and all, but yeah, KSQL DB had some good querying capabilities which I thought I could leverage. Like it's almost similar to Azure DB. Maybe Azure DB is also made of KSQL, but yeah. So I thought the KSQL DB would uh, suffice the architecture whatever we designed. So what happens is that once you get the message in the Kafka topic, there are multiple connectors which publishes data into the KSQL DB, which is also similar as a no schema DB. So the JSON that is published directly comes into the KSQL DB and also the Elasticsearch. So there are two connectors which actually takes from the topics and then it publishes into the Elasticsearch and KSQLDB. So we have a KSQL CLI for someone, analytics dashboard business analytics person. If they want to directly query instead of if they don't like the dashboard, they can actually use the KSQL CLI, just to query it and query. I can come to that point again, but yeah, just assume that you can run queries on the topics, and Elasticsearch is for wider audience, where you know if you want to take data from multiple mobile apps, you don't want to hassle the real server, right, whichever the Kafka cluster or something. So that's where we replicate the data into Elastic Store, where you get a lot of benefits that is clubbed with the Kibana dashboard. So directly you can, the indexing is done on Elasticsearch and it supports JSON very good. So it has automatic schema detection, and then it automatically estimates to that, and you can run some monitoring analytics from the Elasticsearch. Also there are REST APIs exposed. So for the whole architecture, right, like I have chosen the approach of using Docker containers. I'll come to why I have chosen Docker containers for this architecture. uh, you know uh, but it's mostly in my work area. So but yeah, there are a lot of benefits that comes. I know it's mostly one such benefit is the hassle free installation. I'll explain, the flow once I start, going through the code. But let me just walk you through this part where you just see the database schema and the implementation and why we have chosen such a schema. So initial idea was to have some kind of SQL DB, but for analytics and other purposes, I thought maybe why not go with a NoSQL DB, which can support analytics engine inside it. So I thought KSQL DB was a good choice for me. I mean for us, and also so the schema we thought for the mock data that comes from our generator is something. It's just a JSON with some fields, like as you can see here there is a vehicle ID, this is a city, latitude, longitude, and the temperature, humidity, and the speed. So mainly the problem statement looks over this field where you try to detect vehicles which are over speeding, right? So that is the one of the analytics that you can do. Or you can just see like how many vehicle ID, I mean how many drivers are frequently increasing the speed even though if it is not in the city limit. So such analytics can be performed. So we thought, okay, this data structure, this JSON will suffice actually, whatever the problem statement states. uh, in that case, like we have our generator code will change the latitude, longitude, and also the city, because there can be multiple trucks, right? So it should accommodate that also. And since the DBs we use are NoSQL, we can just this is the table data. So in NoSQL, I think the JSON basically sometimes you can configure in such a way that each field is a column in the table, and then you will have multiple entries. So in our case, that's the database schema for the truck driver, where this is the data where the publisher code, the data generator code will just publish and then into the MQTT, and later point it is consumed by Kafka and then later Kibana and KSQLDB. Now let us talk about the simulator program for the truck data movement over the period of time. Yeah, so this is basically my project folder structure. As you can see here, this is the file. I'll walk you through the code. I'll talk about the MQTT stuff, but yeah, let us just talk about the data publisher, the generator part. So what basically I'm doing here is that we have an infinite while loop which sleeps for 5 seconds, and then it's just like continuously streaming data for each vehicle for every 5 seconds. So it's not exactly streaming case, but just to simulate something, at least just like a truck data coming from IOTT, so that latency and all I'm just simulating with this sleep, because it is actually via air, right, by signal. So just to simulate that, this sleep is there. And what happens here is that we just get some weather data, kind of humidity and all, just to mimic it. So we have a API key, and then we just mimic it with the request, and it's just a simple thing, it's nothing complicated, but just to get the vehicle ID and some temperature, humidity stuff. Rest of it is just normal. We just use the randomized coordinates, but yeah, the speed is also randomized from 0 to 150. And it's just that's how. So what we do here is for five. So since we, as you can see here, there are like 5 cities that I have chosen for the simulation. So for each 5 cities I'll be generating one stream packet. I mean, this is the loop is for that. So we just create an object, and then finally we just publish it into the MQTT topic. I'll talk about that from the architecture perspective, but yeah, so just assume that if for the 5 cities you are just running this piece of code for every 5 second of latency delay. So that's how the simulation program. I can just show you. So I'll just comment out the MQTT publishing part, which I'll show you again. As you can see, I'll just run it. So this is how the data is generated. 5 cities, and then again 1 2 3 4 5 seconds, and then again your data starts. So you have speed and the temperature, and also this is the simulator program. It's pretty simple for the use case, but yeah, I thought it will help to simulate everything. So I'll set it back. Now we'll start discussion about task 4 and 5. I'll just explain it together so that I don't need to go again and again for this. So I'll try to start from the architecture again. So this is what, as I explained, right? Like you have your generator program, which I just showed you, which publishes the data into the MQTT topic. That is what the task 4 is about. How do you push the data from the moving truck to central server through the MQTT protocol? And later point, you transfer from the Mosquitto broker to the Kafka topic and the raw storage. So how do you achieve it? Like in our architecture, as I've explained, so I have a Kafka connect cluster, Kafka, and from that point I have multiple connectors, and into the raw storage here is the KSQL DB and also the Elasticsearch. So that is about task 4 and 5. I'll just show you how that is done in the current code base that we have. As I also told, the main the main thing that we used is Docker. So the reason why is like suppose if I want to bring up like multiple Elasticsearch and KSQL DB, Kibana, everything, I have to install everything in my Windows system, right? So I have to configure a lot of environment variables for that to make it work, at least to run it. Even the MQTT broker. So we have some MQTT brokers available in the internet, but I don't want to use that. We come from a mindset in such a way that if I give you a project, you just have to run multiple commands and let's bring that environment up. So I like that kind of code bases where the setup is pretty easy for any developer. Anyone can pick it up and then just run the whole development setup in your local system, and then play with it. So that's where the ideology of this project came from. So that's why I use Docker. So if you see my Docker, so Docker is basically it comes from a container approach. So you have each container is a Linux machine running in your system. So as you can see here, so there are multiple containers normally in my Docker Compose file. So as you know that this Mosquitto is for the Mosquitto broker, Zookeeper is a dependent internal management service for the Kafka, and schema registry is for KSQL DB schema, and you have a Kafka connect, which will provide you infra to connect multiple connectors. Like here, if you want to connect the Kafka to KSQL DB, Kafka to Elasticsearch, so you utilize the Confluent's Kafka connect. So there's a so these are specific images from Confluent for the Kafka connect, and there's a KSQL DB. And if some business analytics a person wants to query on the KSQL DB, so I just provide this extra additional infra. This is purely for development. In production, we can remove the CLI and some external containers, and rest of it, as Elasticsearch and Kibana is for dashboard analytics and the later part of the puzzle. So here it is like for picking up, because I just want to isolate the main Kafka cluster with the data, so that the external users are not increasing the number of consumers on the Kafka cluster. So that's how I thought Here I'll offload the load to a different kind of broker. I mean, it's not a broker exactly, but yeah, it's a different engine, basically Elasticsearch engine. uh, so let me just walk you through the container setup I have. So basically any Docker, right? So you can directly run it with commands, but I like the approach of Docker Compose, which is a YAML spec. But yeah, it's just not plainly taken away, setup. I had to configure a lot of env variables. But yeah, this is just like one-time configuration. It works right away, like in any system. I just tested it in a different system of mine. This is a Windows machine, but I tested it in a Linux system also. So as you can see, I'll come from the beginning. So this is the Mosquitto broker. This is the official image of the Mosquitto container, Eclipse Mosquitto. And in my case, I'm exposing 1833, 1883 port. And here, as you can see, I'm just volume mounting this thing. This is just to mount the Mosquitto configuration here. So this is my code base. You can just walk through it also. I have a Git repo for the whole thing. I'll come to that point again. But yeah, coming to the Mosquitto configuration. Uh, so this is the listener is 1883 port, and the log destination and the persistence true. So this particular thing is important, so that it's exposed to the outer world. So if someone wants to consume the Mosquitto broker, you need to have a listener for that. So the server, basically Mosquitto broker server is exposing 1883 port. So similarly, I have just exposed it here in my Docker configuration. So this is the container setup for my Mosquitto broker. The same thing, like coming to the task 3, right? So here it says like how do you transfer it via MQTT protocol. So since the host name of the container is Mosquitto, so how Docker works is that you are mapping the containers port into the host names port, host machine. Basically host machine is my Windows, so Windows port is actually the Docker helps you to map Windows machines port to the container port 1883. I've kept it similar, but yeah, just assume that there is a bridge, Docker network bridge, so that connects you with the Docker. So here if you go to the initial code with the data generator, uh, so this is the broker address, localhost, the broker port, and I have chosen some topic for in my, in our use case we just thought, okay, truck details underscore MQTT would help us, identifying, differentiate between Kafka and MQTT. So the topic that we have chosen is truck details underscore MQTT. So the client, we create the client here. This is a Python client, Python module PAHO. So it's an official Python module. So it provides your client interface to the uh, the MQTT broker. It's asynchronous client, so that you have callbacks when you get a message. So you start your loop and then you get your callback once you get a message. So it's asynchronous, so it's not blocking the main thread. And so you configure your client, you give a name to it, and so you configure the callback, and then you connect the client. So MQTT broker address is your local host. Just like my Docker Compose, I just have my 1883 port. Similarly, I have my 1883 port and some topic. So you just connect to it, and then yeah, you subscribe is just for printing whether it's coming or not. But normally what I do, I call the infinite data generator code, and then here whatever JSON that I created, convert it to a string, and then just publish it into the topic. So that is the part of task 3 where you publish into the MQTT broker. So this is, I'll show you the running workaround, but yeah, so just assume that the container brings up the broker in your host machine, and then so you just run the demo client Python code to just publish data into the uh, this generator code into the topic, MQTT topic, broker topic. Coming to the architecture again, just to reiterate so that we are not lost in the process. I've just showcased you how I'm generating the data from the Python script that I have, and then I'm publishing it to the message broker. From that point, I'm utilizing Kafka Connect, which is a Confluence project which has multiple connectors. So in my case, what I need is a connector from a MQTT broker to the Kafka cluster, and one more connector for the Kafka Connect to the KSQL DB, and one connector for the Elasticsearch from the Kafka. So this is I'll just come to it from the Docker Compose file. So you have a Zookeeper container which has a couple of environment where the container name is Zookeeper, and you expose the client port as 2181. So if you see the Kafka, I've taken the Confluent Kafka image. It depends on Zookeeper because yeah, Kafka it should be with Zookeeper, so that's a dependency. And the Kafka, see, as you can see here, the Zookeeper, it's 2181, which is the same thing that I've used here, the same environment variable. And the Kafka listener that we have here is 2902. Remember this, this is used a lot in the project. The Kafka, port expose, even though it's 9092, but for internal Docker network, I just use 29092. So that's how you, in the internal to the Docker network, you just try to use 290. I documented it here. And so rest of it are some Kafka environment variables that you need to set. So this is not very much specific to Docker. If you try to install it manually, maybe these are set during the installation steps. So yeah, I've just gone through Mosquitto, Zookeeper, and the Kafka. Next point is the schema registration. So this is just taken from Confluent. So for KSQL, if you want to have some schema registry, this is just the schema registry container, and this is the core heart of the project, Kafka Connect, Confluent's Kafka Connect. So this is this configuration is pretty hefty, but the way Kafka Connect works is that you can uh, you know whatever you can additionally install multiple connectors. And as I told you, here in my case, one such connector is from MQTT, the other one is the Elasticsearch and the KSQL DB. So here basically the environment variables is that it has to connect to Kafka, right? So as I told you, the Kafka listener is 29092. So as you can see here, it's the same, the connect bootstrap server, because I have created the setup in such a way that you don't need to create a topic. Like suppose if I am starting up a project new, and if there is no topic called A, we don't want you to create the topic again manually, and also that's where the bootstrap servers come from. So Kafka Connect helps you. So you need to provide the bootstrap server, and then uh, so since that whatever Kafka stores is byte data, that's why it has some key and value converter. So Confluent uses Avro, which is their own deserialize and serializing input and output. I'll come to that. So just assume that Kafka Connect container is up, and it is depending on Kafka Mosquitto and schema registry, as I told you. And a couple of prerequisite commands that I run before starting up the container is just to install both the connectors, MQTT and the Elasticsearch. So this is the command. Normally, if you install the Kafka Connect in a system, you have to run this in manually, finding the binary of Confluent Hub. You just say that okay, I need the connector code for the MQTT, and I need the Elasticsearch connector. So in my case, since it's a container, I'm just running it inside the container, these two commands, and then yeah, just waiting for the container to come up just to print it. So this is very minimal setup of Kafka Connect. And so rest of it is, once you configure your Kafka Connect, you have your connectors code installed. You just need to you know bring up your KSQL DB and Elasticsearch, so that once you start pushing the data, since everything is configured automatically, it works in the flow. That's the pipeline, whole pipeline. So the KSQL DB, it is dependent on Kafka Connect, obviously, and also Kafka, because KSQL DB just replicates the Kafka topic. And as I told you, again here I am using the Kafka listener 29092, and also the Kafka Connect. So in terms of Docker, you can always refer to the host name. So if you go to Kafka Connect, the container name is Kafka Connect. That's your host name exposed, and the port is 8083. So 8083. So you can, so this, there is a REST API exposed for Kafka Connect. I'll come to that again. But yeah, so KSQL is dependent on Kafka and Kafka Connect, and it exposes 8088 port. And this part of the puzzle is KSQL CLI. So that is the CLI, it only depends on KSQL DB and the Kafka, and it's a SH entry point. So this is I'll show you everything, and then the last part is the Elasticsearch and the Kibana. So Elasticsearch exposes 92009300 port, and also Kibana is dependent on Elasticsearch. It's just a visualization tool on top of Elasticsearch, so you can have meaningful insights like from dashboard. You don't want to implement everything, right? Like, I mean, you can implement Elasticsearch exposes an API, but yeah, Kibana comes up with a proper UI, which is used for analytics by a lot of people, Apache Kibana. So yeah, so this is the whole Docker setup. So coming to this, so how do you transfer the data from Mosquitto Broker to Kafka topic? It's via the Kafka Connect, the connector. So the connector is basically, so since I've told you there's a Kafka Connect is exposing a REST API at 8083 port. So what you need to do is that you need to configure that Kafka Connect, saying that okay, I have a MQTT broker which is running at 1883 port. So again I'll come back here, 1883, same, right? So that is, so you have to say that okay, I need a MQTT source connector, and I need to have the MQTT broker Mosquitto hostname running at 1883 port, which the topic name is struct details MQTT, right? So if you go to the data, yeah, so it's the same. So you have that, and the final Kafka topic that you want to publish, truck details Kafka. And since I told you the serialization, you need to convert it into string, so I just use a byte array converter. So these are all like specific to my use case. Since I've chosen the data structure something similar to JSON, I have to update the configuration like this. So it depends on how you, so if you have a CSV, then you need to have a different value converter. And again, coming here, the bootstrap server is 2902. So yeah, that's again the same thing, and then you just run this, so that this, as I told you, 8083 port is Kafka Connect exposing it, 8083, and then yeah, so this will actually configure this part where you say MQTT connector to Kafka. So yeah, so that's how you transfer the data transfer using the config. I'll cover all the tasks running the program. So I'll just try to run some filtering program which will try to identify overspeeding cases, and yeah, I can show you some statistics, and I can show you some interface how you see all these things. So we have a couple of containers, dependent containers that we need to bring up, right? Like one is the MQTT message broker, one is the Kafka Connect, one is KSQL DB, Elasticsearch, and KSQL CLI. So I'll come from that. So this is my terminal. I mean, currently in my project structure, if you see, these are my and I just need to refer to this Docker Compose, right, file. So I'll just say Docker Compose up. So it just creates all the containers. So it starts from Zookeeper, Kafka, dependencies and all that dependency tree. It starts the Kibana, schema registry, Kafka. So these are all the logs spilling out from the containers. Like if you can see here, I'm just all the containers are running, like whatever I've shown you over there, and yeah. So as I told you, so you need to set up your connector, right? MQTT to Kafka Connect and also the other container. So how do you do that? Is you just need to configure, tell Kafka Connect, tell this guy that okay, I have a MQTT broker. As I told you, I have a MQTT broker and I have a Kafka Connect, Kafka topic. So just connect them. That's how you talk to the thread. So this is how you talk to the Kafka Connect. This is the schema that it understands. So what I'll try to do, I'll try to just run this curl command. So this is the endpoint that the Kafka Connect exposes. So I'll just bring up my bash. I'll just run it. So as you can see, it gave you an output, and also if you can see here, it says connecting to the MQTT server. So what happened here is that I'm running an MQTT server, right? Like if you see here, so so my MQTT Mosquito is actually exposing 1883. This is rare, right? So the same thing, Kafka connector. This connector, gave the log saying it connected, and it subscribed to the topic, truck details MQTT, which will be trying to publish the data into that. And what we'll try to do, we'll try to set up the other connector, which is Kafka to Elasticsearch, which which will come in handy once we publish the data into the MQTT broker. But yeah, before that we'll try to just run this command. Usually we can run it from a Python script, but yeah, again running a curl command, you have to use a popen or something. But for the time being, I'm just running it from the command line itself, the curl command. So this is another Elasticsearch sync connector, because you are trying to sync into the Elasticsearch, right? So you just need to run this, and here you need a JSON converter. So I'm just running the command again. So yeah, so it gave an output. So if you can see here, this is the data that I sent, and the Kafka connect, basically if you scroll down, these are the logs. So it says truck details Kafka. So as I told you, there is a bootstrap configuration which I've bootstrap server which I've given. So that's how it, even though the topic is not there, it is creating that topic, and then Elasticsearch is an indexing engine, right? So it created an index also in Elasticsearch, and so that's how I just showed you, like how you create your two connectors, and just to showcase you what it is, I can just run a simple command. Just a second. So yeah, so it is giving you full response, right? So basically your connectors are loaded, and as you can see here, so it says truck details Kafka created in Elasticsearch, and also both the connectors are set up. So now I'll come to this part where how do you try to filter out overspeeding case. So for that we need to start generating some data, right? So what I'll do, I'll come to my another shell instance. So as you can see here, this is a virtual environment which I created. So I've also documented about it, how do you bring up your virtual environment. So you just say virtual environment create, and then you install the requirements. So the only requirements that you need is the PAHO MQTT client and the requests. So that's, so if you see here, this is my virtual environment, like, so if you can so it's running Python 3.9, and yeah, so if I say which Python, sorry, so but yeah, normally it works in Linux. So I'll try to start the data generator part. So this is the file, right? MQTT client data gen. So once you start it, automatically it pumps the data into the truck details MQTT topic, and since we already have connectors, I'll just show you how it works. So I will start it. So it started publishing into the topics, and as you can see here, so it's flushing out messages into the connectors one by one, and so how do you ensure that whether there is messages in the Kafka or not? So this is so what I'll do, I'll just say, so this is how you go into container. So what I'm trying to do, just like a business analyst, I'll get my CLI, right? So in Docker, you just go into that machine, and yeah, this is your KSQL DB CLI. So if I say show topics, so there are multiple ways to figure out what is there in the topic. You have Kafka cat, you have Kafka consumer shell scripts, ready-made shell scripts, but so this is one way. So here, as you can see, there is this truck details Kafka, right? So so this is the topic which basically I've configured, right? Like, so once you say that this one, so yeah, from the MQTT it picks up the messages and it will be there. So since this code is continuously running, we'll try to see whether it's coming in real time or not. So for that, what I'll do, in KSQL there is this stream you can create. So what I'll do, I'll just create a stream which is some name truck stream. I'll just pick two fields for the time being from the JSON, vehicle ID and the speed, and the topic, as you know, truck details, and the JSON format. So it says stream created, right? So now you try to run some query on the stream, but yeah, in our case we say speed greater than 100 because uh, we just trying to identify overspeeding cases. So in my, so if you want, we can say okay, greater than 60 is overspeeding, then yeah, fine. So what I'm trying to do now is just I'm trying to run a streaming query. So what happens, so if the data, if it is coming, then yeah, so as you can see here, this is just live data pumping here. So if this is 90, right? So I think you'll get that 9213, 9213, yeah, 921390, yeah. So this one, so this is directly pumping data. The MQTT, the connector, is pumping data into the Kafka topic, and I'm just trying to run a filtering query on top of it. So this is just how you know filter data for overspeeding cases. So if a business analyst, if he wants to analyze live data, so he can just come to the KSQL uh, prompt, and then there is other options also. You can create materialized views and then store it in some tables and later use the table for other consumption, but for the demo purpose I'm just showing you here itself, so that you can see the live feed coming out from the program. So as you can see, this is still running, right? Like, so yeah, it's still running, so speed is 10, so you won't see this entry, but yeah, so this is 130, right? 9213 again, I think you'll see that, yeah. So 9213, so this is the live feed, but so you want to even check the other part of it, right? So how do you check whether it's going into Elasticsearch? So that's where we you know so how do you have statistics of speeding cases and all? As I told you, like, you can maintain this table and then monitor this, or you can, so this table is permanent, right? So streaming table, so you can have it and then later use it for later point of analytics, like statistics and all. So you can run your ML algorithms and all. You can identify which part of which driver is overspeeding or something like that. So coming to task 8, so how do you have a simple interface? So this is all fine. So some kind of people, so there are kinds of people who don't like the CLI approach. Like, if I'm not a business analyst, if I don't know how to run the queries, I just need a simple, if I'm a normal user, so I just need some kind of dashboard for me to visualize all the stuff. That's what the task 8 says, a simple interface to show, because some people, they don't want to understand the technicalities. So if I give this software to someone, right, so they just don't want to understand, like, what all internals are there, or what is this architecture. They just need a particular URL, and then they just need some kind of, at least the basic, like, just like if Jira, right? Jira is a software where you just run simple queries and then it automatically works. So if you want to emulate something like that, that's where these two containers help, Elasticsearch and Kibana. So since I've already told you there is a connector pumping into Elasticsearch and all, so how do you check it? Like, how do you check whether your Elastic is configured? So you just say you configure your Elasticsearch with your Kibana, and so if I need to run some simple, what do you call that, interface query, like to see overspeeding case, or at least check whether data is ingested into the Elasticsearch, let me just show you how that is there. So since, as you can see here, this program is again running, right? So if I run this stream query, it still gives you data overspeeding cases. So the data is still getting pumped into the Kafka topics, and later also into Elasticsearch. So I just want to show you whether it's there in the Elasticsearch or not. So you can interact with the Elasticsearch API, run it. So yeah, so as you can see here, there are different uh, search patterns, and then here you can see there are multiple things coming into the Elasticsearch, uh, you know and yeah, so there are like lot of hits, and then 746 hits in Elasticsearch engine. So if I want to go to the overview, discover, so as you can see 740 just showed you right in the API. So these are all coming directly from the Kafka. So that's how you validate like the other end of the pipeline, where you push the data from Kafka to Elasticsearch. And yeah, so it's actually coming into the so if I refresh it, it might show, yeah, it increased, because yeah, obviously it's a streaming data, it continuously updates. So that's where, so just imagine that, you are, so if you don't have this Elasticsearch, the customers or whatever end users are directly pulling data from Kafka. So it's too much load, right? Like you need to have multiple load balancer. That's where our architecture helps you in such a way that I am splitting up the traffic, complete traffic. So the only consumer from Kafka is KSQL and Elasticsearch. Not the rest of the people. They can, the Elasticsearch can load balance, and they only use Elasticsearch, which is a just a data read-only source for other end users. So that's how that's also security was integrity, because no one is tampering with the original data source. So yeah, and coming to the part where how do you show a simple interface. So this Kibana, here in my case I can just select speed. As you can see here, there is this top 5 values like 80, 55, 145. Like it shows you how many entries are there. If I say visualize, it will just show you a simple bar chart. I mean, it's up to the analyst. They can configure, like they can even run KSQL queries here and then create their own chart. But for the time being, it is just showing that how many 130 speed are there, how many 145. So you can even group by vehicle ID and then figure out that what is the trend of the vehicle guy. Like, I mean, how much he is actually, you know uh, going, like speed, like what is his distribution of the speed and all. So that kind of power you have. So that's it with the Kibana. Like I think that will answer the question, like how do you show. So it's like a lot you can do, not only this. So you can see here, like visualize, you can say, you can create, there are a lot of heat map, other region maps, area data. You can, it's up to you, like since the data pipeline is set up, so yeah, it's up to us, like whatever you want we can just query. That's it. So it's just live streaming data, it's coming again and again. And so yeah, so see 870 hits, right? It was like somewhere around 700, so it's streaming again and continuously streaming. Yeah, so that's where the architecture. So I've showed you end to end. So how you generate the data, how you uh, you know how you just push it to till the monitoring aspect, and how do you query from the KSQL. So that is our way of running this end to end. I hope I have cleared out everything. I'll also upload the GitHub repo for the same project, so that you can try to run it in your system. It works, but yeah. So I'll provide you a README. I'll update the README to bring up how do you bring up all these things and all. So it's pretty simple setup. Just bring up your container and then create your virtual environment, run the client, and then configure your connectors. So yeah, that's it, folks. I hope this is, I've just covered all the tasks. Yeah, thank you everyone.